Good afternoon, everyone. Today we're going to continue our discussion on the ARIMA model. We said that ARIMA is one of the most powerful model to be used in time series. However, there are some conditions that have to be met before we can use the model. And that condition is that your time series data should be converted into a stationary data. So we have learned the process of converting a time series data that's not stationary into a stationary data series. Okay, either not stationary in mean or not stationary in variance. We said that the transformations that we can do is either is to get the trend your data, okay, and also to get the log of the data. In terms of order, we first need to get the log and then get the difference. So getting the difference log data is actually getting what, class? What is it equivalent to? Getting the difference of the log of your time series is equivalent to, class? Anyone, please? Getting the difference of the log time series is equivalent to what? You may unmute yourself or chat, please.
The
Class?
returns.
Yes, correct. Thank you. Yeah, it's equivalent to getting, yeah. Thank you, Abby. Who was the one who answered a while ago? Who was that? Yeah, thank you, Raul. Yeah, you're correct. So Raul and Abby, thank you so much. You're correct. It's equivalent to getting the returns. So in answer to the question, which should we use? If the difference of the data series is already stationary, okay, do we still need to get the log first and get the difference? Well, it really depends. If you're getting the returns, the log returns, then you should get the log first and then get the difference. Because just by getting the difference, you're not actually getting the returns. And as we learned last time also, getting the returns, log returns of a data can be easily done using quant mode. We showed last time that if we get the daily returns function, if you use that, it's equivalent to getting the log, the difference of the log time series. Okay, so it depends on your objective. It depends on what you're trying to do with your model. If you're just modeling your time series, okay, and if just getting the difference is sufficient to make it stationary, then do that. You don't have to get the log. Okay, and the rationale for that is, what's the reason why you would want to make your model as simple as possible, class? Anyone, please? For example, you're modeling the prices. Why is it that it would be better just to use the difference time series instead of the difference log time series? If in both cases, both transformations already lead to stationary data series. Why is that so, class? What's the rationale for that? Hello, class? You can chat or, okay, efficiency, you're correct. Fewer errors, it may not be necessarily so, but efficiency, yes. And also less steps, okay? Less steps if you use a difference. And also, class, when you predict your time series, you will be getting the prediction of your transformed data. Make it easier to troubleshoot. Maybe yes, maybe no also. But the main difference is that when you predict, okay, you might need to revert back to, for example, prices. No? You will be needing to revert back to the original data. So you just can't present the forecast, the prediction, let's say for the next 10 days of your transformed data set. That will not mean anything. So you'll have to do some steps in order to convert it back to the original data set. Okay? So simplicity, parsimonious model is better appreciated. So once we have transformed the data into a stationary data series, okay, what do we do next? Now, before, what we do is to plot the ACF and the PACF. Okay, and what's the rationale for that? Plotting the ACF and the PACF will allow us to determine what could be the candidate for the best model for our time series. Okay, so those were the days when you really have to plot your ACF and PACF manually, and then from there determine what model could best describe your data. So is it an AR model, an MA model, an ARMA model? Okay, and sometimes that can be very difficult. In some cases, the ACF and PACF could easily tell you, this is an AR model, or this is an MA model, or this is an ARMA model. But often also is the case, you can. So what happens? You have to do some iteration, trial and error. And once you have several models, you'll have to compute the AIC for each. That can be very tedious. And you have to choose the model that gives us the least AIC information loss, a KAIKI information criterion. Okay? So those were the days when you have to do that manually. But now, class, it's all different. In the advent of technology, in the advent of softwares, freeware like R, Python, you're easily able to determine already the model, even without going through the plot of the ACF and the PACF. But for our purposes, you will still, for example, sa exam nyo, you will still need to plot the ACF and the PACF. Okay, and perhaps venture a guess what the plot tell us about the possible model. Okay, so that's what we did last time. What we did was okay, so we run this model, right? Partition MF row C is equal to 1 to 2. Okay, and then we created this object A1. It's an autocorrelation function. This ACF, this small a, comes from your stats package. So there's no special software that we need. Stats package, ACF, and also this one, stats. There's no package that we need to install for this. It's preloaded. And then once you create the A1 object, then we plot. Okay, so let's run this together. We have done this last time, so let me just briefly review this. Okay, so it gives us this PACF, and the other one is your ACF. Hindi siya nagpa-partition, no? If I just run this, itong dalawang to, hindi ko na ipa-partition. Okay? It will give us this one. So this is your ACF. Okay. So from the ACF, this is log 0, right? So that's why it's 1, because the time series is perfectly correlated with itself. Kaya nga 1 ton. But 1, 2, 3, 1, 2, 3, 4, 5. So this one is your second. Seems to be quite significant here. Okay, quite significant here. Okay, but more or less parang wala na siyang except for maybe yung number 2. So the ACF seems to indicate that this could be an MA model, di ba? So this is indicative that this is an MA model because we have cutoffs here. And then if you take a look at, pero mukhang MA2, so possibly MA2. Okay, but if you take a look at the PACF, so pwede siyang slow decay, no? Tailing off. Kasi yung tailing off class, pwedeng both sides yan. No? Okay, it looks like a tail off yung PACF. So this could indicate class significant spike at ACF, tail off, slow decay at PACF, then this could be an MA process. Okay, but it's not really that apparent. No? So medyo mahirap din to determine. No? And you can use the other autocorrelation function. This one, the capital ACF, comes from the FINTS, Fin Time Series package. And then this one, the capital P, ACF comes from the forecast package. And then, so let's once again create a plot of that. All right, so here you can see, dito makikita natin yung mga, so this is significant at log 2. Also here significant at log 4, no? Okay, so ACF significant at log 2, significant at log 4. Tapos meron pa tayo dito sa larger logs, no? May mga significant pa tayo dito. Okay, but this could seem to indicate that perhaps this is an MA4, no? Kasi ito, just like the other one, okay, mukhang tail off to, no? Slow decay siya. Okay, ano siya, yung what do you call that? What's the term for that? It changes signs, no? All right, so based on this, my guess is that it can be MA2 or it can be MA4. Okay, but based on that, we're not really sure. So one last thing, class, we can use the TSM package. This is also a good package to use for the AC function. Okay, just need one function, AC lang, because this automatically will plot both the ACF and the PACF. Okay, remember class, we're using the DL-BUD, okay, the difference and log time series natin, which is technically modeling our returns ng BUD, no? Okay, if I run this, then we have this. The disadvantage of the AC is that, okay, although it's in one plot, pero it's too small really to look at it intuitively or meaningfully. Mas maganda tong, I prefer this, no? Yung itong ACF, kasi you can plot it really separately and then you can see more clearly. And also the capital ACF. Ito. Diba, this then we can see. Okay, so of course, if I was guessing MA4, it will not stop there. I will have to look at other possible models. So nowadays, class, it's not hard kasi we can make use of the ARIMA function, auto.arima. Okay, we did this last time, so just a quick review. So we're creating this object mod1, and last time we said that mod1 will be a list. It will contain several types of several data types. So we use auto.arima of our object difference log bud, and then we summarize this. When we generate this, we can see that R gives us an ARIMA 004, which is what the ACF function seems to indicate, no? So dito, medyo tama tayo dun sa pag-read natin dun. So this is an MA4 MA4 model. And these are the coefficients. So last time we learned how to generate the equation. We said that the equation for this is, let's annotate this. Sabi natin, ang model natin is we're modeling DL-BUD, right? DL-BUD sub T is equal to, so we have your MA, MA2, MA3, and MA4. There's no mean. Walang binigay sa atin na average, so we don't have that alpha or alpha value. So our model will be 0.0031. Your MA will be your epsilon T minus 1, log 1 of your error term. And then plus 0.0478 epsilon T minus 2, right? This is your MA2, log 2. This is your coefficient. Okay. Remember class, our MA function, MA, let's say MA1 is equal to, you have a certain constant, let's call it alpha, plus your theta 1 times your error term plus your error term at time t. Sometimes we write this in front. Doesn't matter anyway. Okay. So, and then we have another addition, the third log component. So that's negative 0.0259 epsilon t minus 3, and then plus negative 0.0361 epsilon t minus 4. Okay. And then, of course, we write epsilon sub t plus. Okay. The error at this period. And then we don't have an alpha kasi wala naman tayong wala tayong constant dito. Okay, any questions, class? Any clarifications? Any questions so far? Clear ba yung Clear ba yung pag-generate na equation ng MA model natin? Paki-chat please. What sayeth thou? Okay, okay, good. Thank you. Thank you. All right, so let me clear this first. Okay, nawala yung clear. Clear all the drawings. Okay, good. All right. Then we said that we can include, in order for us to look at the different models that was tried by R, we can include this trace is equal to true. The trace is equal to true function added to our auto.arima will generate a list of the models that was developed by R or determined by R, and then it will give us some metrics of the AIC. Then summarize ulit natin. Let's run this. Okay, you can now see, class, that here. No? So, what was the model that was generated? Pareho lang din naman, no? It's ARIMA 004. Okay, best model, ARIMA 004 with zero mean. Okay, that's why it's not giving us the value of a constant of a mean. And the coefficients are still the same. Okay. By the way, class, sometimes you will not get the same values for this one. Okay, because this one is generated by approximations. This one, kaya sinabi dito, class, if you take a look at this one, refit the best model without approximations. Okay? Because when R develops this, generates this, in order to speed up the computation, it approximates first. And then finally here, it says, refit the best model without approximations. And then we get the same answer, ARIMA 004. Okay, and if you take a look at this ARIMA 004, the AIC is negative 18086. So if you compare that with the other AIC, this is the lowest AIC. Okay, negative siya, class, ha? Kaya the higher the value of the negative, the lower it is. But you cannot find any other AIC that's lower than this one. That's why this was the chosen model. Okay? All right. Any questions so far, class? Any questions? Clear so far? Okay, good. Thank you. I'll always appreciate, class, your feedback. Okay, as I said, always do not be ashamed to ask questions. Do not be ashamed to clarify. Okay, so before we continue, class, what we have actually discussed this last time. I think we also did we generate yung arima.ar1.small class last time? Did we run this? This one? We did, right? We were able to do that because POSIT was working last time during our class. Sa kabilang section, it was not. Okay, so I hope you don't mind us reviewing. But let me just discuss with you this one. which I discussed with the other class. Okay, where's that? Okay, this one. Okay, so let me just discuss with you some notations. Okay. Okay, so let me use the red ink here. Let me just use this writing. Oh, sige. Okay, I think let me just delete everything. Okay, let's just be familiarized with some notations in ARIMA. Okay, let me delete this. Dapat Control A ko na lang. Control A, delete. Okay, yun, shortcut. All right, so let me quick review class. An AR1 process. Where's my pen? Okay, if you recall, by way of review, AR1 process class, diba? We write it as y sub t is equal to, you have your, let's just remove the mean or the constant. Let's just focus on the that a model with no mean, phi1 times y sub t minus 1, and then plus error term. Okay, so that's your AR1. And your ARP process, order P, so your y sub t is equal to phi sub 1, y sub t minus 1, plus phi sub 2, y sub t minus 2, okay? You're creating P lags, right? Plus, dot, 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 plus, say, phi sub P minus 1, okay, the second to the last, times phi sub, sorry, times y sub t minus P minus 1, okay? Plus, the last one is phi sub P, y sub P, because we have an AR of order P, and then y sub t minus P. So this is an general AR sub P model. We can write this to generalize this. We can, because this is quite long to write. So we can write this as y sub t is equal to, so we just use the summation sign, sum of your phi sub 1 is variable, right? So we can write that as phi sub I, okay? And then your y sub t minus I. And then you have your epsilon sub t here. And then your I will range from I is equal to 1 up to I is equal to P. All right, so that's the that's also another way, mathematical way to write your, this is your ARP process, right? Just use the Riemann sum notation. This is just to shortcut it kasi mahaba ito, no? Okay, any questions about this? Any questions about how we wrote our ARP process? Again, may I request, if that's clear, yung notation niya, kindly chat, click yes. I guess you know naman yung summation notation. So we just generalize it. Kindly chat if it's clear. Yes or no, please, in our chat box. Unless you have any clarification or you have any question. Okay, good. Thank you. Okay, now another notation which I'd like to introduce to you, kasi baka pag nagbabasa din kayo ng mga journals, you might encounter these notations. Also, the notation that, let me write this, y sub t minus 1 actually can be written as backshift operator of y sub t. So this means backshift, this is the backshift operator. So you're getting actually the lag, LAG, backshift operator B. Okay, others call this L, no? You'll see in other nomenclature, it's called your L sub t. So they're the same, whether you use B or you use L. Okay? So if it's y sub t minus 2, it's just equal to B squared. Okay? B squared times y sub t. 2 here means you're going to log this the second time. That's why it's y sub t minus 2. So if, let's say it's y sub t minus p. So that's the pth log. So that will be b to the p times y sub t. All right, so that's your backshift operator. All right, so your equation can now look like as, so let's say your AR1, where's that? This one thing that's difficult with. Okay, so y sub t is equal to phi1, okay, times b y sub t, right? Because this is your, if there's no exponent here, that means this is 1. So backshift or log of yt is simply your yt minus 1, and then plus error term. So sometimes you'll see this, okay, which is your just AR1 process because your backshift, or sometimes, as I said, others use L. This is your log. Okay? Any questions, class? So far, any questions? Okay. Alright, tapos, dito ako nahihirapan. Di ko alam kung paano ako pupunta sa next page. Wait, insert ba? Insert. Aso sa taas. Okay, anyway, so I'll just try it here. Nag-insert nga siya sa taas. I wanted it to, dapat page break ba? Ayaw rin eh. Okay, anyway, so therefore, class, if we're writing, for example, if we're writing y sub t is equal to the phi1 y sub t minus 1 plus phi2 y sub t minus 2. Let's say you have an AR3 process, phi3 y sub t minus 3 plus your error term. So this can be written as y sub t is equal to phi1 b y sub t plus phi2 b squared y sub t plus phi3 b to the third y sub t. Okay? Plus epsilon sub t. And when you transpose this, ba magiging ano to? Y sub t minus the whole equation, di ba? The whole equation minus phi sub 1 b y sub t minus phi sub 2 b squared y sub t minus b sub 3 b to the third y sub t. Okay, so you can factor out your y sub t. So this becomes y sub t is equal to 1, okay, minus phi 1 b, okay, minus phi 2 b squared minus phi 3 b cubed. is equal to epsilon sub t. Okay, so that's your equation actually to get the roots. Okay, to get the roots to solve for the b's of your equation. Okay, so I just like to introduce that for us to be familiar. Kasi you might be reading some text, or you might be reading or researching on, and you can see that in some literature you'll be seeing this b, or others call this L, itong backshift operator. So yun lang ibig sabihin nun. Okay, your y sub t minus 1, the log of y sub t is actually equal to b y sub t. Okay, clear class? Clear? Kindly chat please if we're clear so far. Okay, thank you. All right, thank you for those feedback. Okay, let's quickly go back to what we did last time. Now, up to at least AR2 and MA2, I want you to know the characteristics of your coefficients. So for phi1, for AR1, for example, the coefficient is phi1. Okay. And we can write this as your phi1, which is this one. Okay, phi1, right? Which is the coefficient of an AR1 process. It should be between -1 and 1. Or in other words, it can be written as the absolute value of phi1. Let me just write phi1 should be less than 1. Okay, so this is what that means. -1, phi1, between phi1 is between -1 and 1. So that's the same as getting the absolute value of phi1 is less than 1. Okay, it cannot be greater than 1. Okay, we might not be able to reach that point today, but we're going to reach that point next meeting. And then we're going to show what happens if you're in your equation, in your AR1 model, this one, what happens if in your AR1 model, your phi, this one, your phi sub 1 is equal to 1. In other words, your model becomes y sub t is equal to y sub t minus 1. Okay, let me write that. Our model now becomes if phi1 is equal to 1, okay, what will happen? Because we said that in an AR1 model, the restriction is that your phi1 cannot be greater than 1. So what if it's equal to 1? So we now have a process where y sub t is equal to y sub t minus 1 plus epsilon sub t. Okay? You may wish to try to create an object, no? Subukan nyo class mag-create ng object, okay, ng y sub t. Okay, and then i-plot nyo class yung y sub t and y sub t minus 1. Okay? Imo-model nyo muna, class. Maybe I'll leave that as an assignment. Now, this is actually called a random walk. Ang tawag dyan, random walk. If your phi1 is equal to, ito yung coefficient ni y sub t minus 1. If this is equal to 1, then this is called a random walk. And then kasi may error term tayo dito, it's called random walk with drift. It's called random walk with drift. Ibig sabihin ng drift class, it meanders. Yung word na meanders, no? Ibig sabihin kung saan pupunta yan, no? Okay, random walk yan. It's so difficult to predict that kasi kung saan lang pupunta yan, wala siyang magiging observed pattern. Okay? And it will be a non-stationary data. Okay? Clear yung class? So that's why hindi pa pwede class pag nag-model tayo ng AR1, hindi pa pwede yung phi1. This cannot be. This cannot be. Hence, there are restrictions on the value of your coefficients. Sabi natin si phi1, absolute value niyan should be less than 1. It cannot be greater than 1. It cannot be equal to 1. If it's equal to 1, we said that it's a random walk with drift kasi may error tayo dyan, ano? Random walk with drift. And what's the nature of this? This is a non-stationary data. Non-stationary yan. Okay? It's a non-stationary, and others call this non-stationary explosive series. Bakit? It can go up, 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 no? It can meander going up or it can meander going down. So definitely, hindi magiging ARIMA process yan, no? Kasi hindi naman siya stationary. Okay? So if the phi1 is equal to 1, then that ceases to be a stationary data series. Okay? So just a by way of reminder that when you do ARIMA, the results should indicate that your phi1 should be less than 1. Okay, whether it's negative or positive, dapat less than 1 or less than or greater than negative 1. Ibig sabihin, hindi siya pwedeng maging negative 2. O basta ang absolute value niya, okay, less than 1. Okay, so I hope, dito tayo sa ano. I hope that's clear, class, so far. Clear ba? Ito yun, ano? Your phi1 is between negative 1 and 1, or absolute value ng phi1 should be less than 1. Same thing with your MA process, your theta1. Ito. Here. Your theta1 process, which is the coefficient that we use for MA. Okay? Parang naging standard siya. Although other writers will use a different notation for MA. It's okay. Alam naman natin, in our case, and maraming gumagamit ito, yung theta1 nila, yung coefficient ng MA. So, ganun din si MA1 class, no? Yung theta1 should be also between negative 1 and 1. All right? Okay. So what we did last time was we simulate. So here, I'll just go through this quickly, di ba? We're creating this mean equal to 1, and then set that seed tayo so that we have the same values. Okay? And then we're creating this, we're simulating a, so initially, ang ginamit lang natin 500. Let me go back there. 500. We're using this function, arima.sim. Question, class, saan galing na package to? Yung arima.sim na to. Answer, please. Okay, may nag-chat. So this comes from your... Okay. How did you check, Jerome?
I did yung sa may console po, sir, yung double question mark.
Okay, all right. Sige, tama, no? So that's the help function. So this comes from your paki-verify class. Did you also get stats package? So if it's coming from stats, is there a need to upload, install the stats package, class? How about the others? Did you get stats? Waiting for your response, class. Okay, thank you. Yan, at least consistent tayo, no? So if it's coming from the stats package, then no need to install that package kasi it comes preloaded with R. Kasama na siya. Pag linode mo yung si R, pag inopen mo, automatic yun. Try one time, next time you open R, go to packages and look for stats. STATS. You'll find that it's already clicked. No? Naka-check na siya. Kasi automatically naka-load na yan. All right, so let's go here. And we were simulating an AR1 process. And how do I know that it will simulate an AR1 process? 100 observations. And then we specify here the model list is AR. Sinabi natin AR, no? And it's 0.1. So this is the phi1. It's less than 1. So pwede, no? Okay, with the standard deviation is equal to 1 and then plus the mean of 1. Okay, so let's run this. We should have the same. Tapos i-ano lang natin, class. Kunin natin tong head. So that we can compare if we have the same values. Okay, so let me run also your head, the head. Okay, so run ko to, Control Enter. Okay. So this is a time series. First 6 observations, no? Kasi head is equal to 6. So kindly acknowledge, class, if we have the same values. I just want to reiterate that the set.seed will allow us to have the same set of values if we're simulating or generating randomly. Chat please, class, if we have the same values. Okay, good. Thank you. Huh? Different values, Patrice, different values. Are you sure? Did you run this? Nag-set.seed ka ba, Patrice? Please check your code chunk. Set.seed 1, 2, 3, 4. Then check your code. Standard deviation is equal to 1. And then may plus A. O yan, that's the complete equation. Inad natin yung mean natin na 1. I'll give you a few seconds, no? For those of you who are getting the different values. Sige, paki-check. Any difference here, for example, naging ibang value yung SD, mababago talaga, class, yung ano, yung randomly generated natin na values. Okay, Patrice, nag-add up na ba? Okay, what was different, Patrice? Anong ginawa mo? Patrice, what did you do to correct the values? Saan ba nagkamali? Saan na iba yung code mo? Hello, Patrice. Ito na pala, sorry. Actually, hindi mo naman yung stats. I wonder why. Kasi sabi nga natin, di ba, you don't need to write stats here. Kasi it comes pre-packaged with R. Okay, baka yung N mo 500. Kasi pag iba to, then iba yung ano. Standard deviation mo 1. And then did you add A sub O is equal to 1? Okay, dapat pare-pareho yan. So there should have been no reason for you to have different values. So thank you for telling me na na-address na, no? And then if we plot this class, if we plot this, Control Enter. Okay, how will the plot look like? Ay, mali, hindi Control Enter. Asan na ako? So tayo sa where am I? Okay. Saan na ba ako? Na-plot ko na ba? Yeah. Okay, we can see here, class, yung plot. No? It's stationary. Expect natin yun kasi AR1 process yan eh. Sabi natin kapag AR1, MA1, etc., these are supposed to be stationary time series. Kaya no trend, no constancy in none, variance is constant. Okay, so what else? Okay, we simulated that object, di ba? Meron tayong object na AR1 small. Ito yun. AR1 small, ito. So it's 500 observations. All right, then we can get the ACF and the PACF. Okay, so let's use this one. Let's use the ACF and the PACF function of this one, of fin time series and forecast. So let me run this. Okay. All right. So, di ba, AR1 yung model natin, di ba? AR1. So, let's check if indeed the PACF and the ACF will approve of its ano. So, dito class, di ba, significant at lag 1. Okay, and then this one is although medyo hindi siya ano kasi 0.1 to di ba? Yung AR1 natin na Phi1 is 0.1, ito mga 0.18. So you can see here that there seems to be a hindi masyadong medyo may pagka accurate yung prediction kasi ito 0.18 when in fact we identified the AR1, the Phi1 to be 0.1. The rest is not significant. So mukhang there's a possibility na AR process to, no? Which we know na AR process naman talaga. Dito naman sa ACF, medyo hard to think din, no? Pero mukhang parang may pagka-slow decay din siya. It seems to have a slow decay. Alright? So ang guess natin dito, pwede siya maging AR1 process. But we know that it's an AR1 process. So this was not surprising at all. In fact, yan, no? Since this is simulated data, ang ginamit natin 0.1. Siyempre, pag simulation class, ano yan, hindi, when we try to plot yung ACF at saka PACF, hindi siya magiging eksaktong 0.1. And then here, okay, let's take a look at, let's use the ARIMA function in order to predict yung model natin. So this comes from the forecast package using the capital A ARIMA, and then ano yung object natin, AR1.small. Tapos ito yung order natin, 100, which means order 1 ng AR, 0 yung difference, 0 yung MA. Then let's include a constant here. Okay, let's run this. Isa na ako. What happened? Ito here. Okay, this is what was generated, no? So si AR1.small, ang sabi ni R, it's an ARIMA 100, which is right naman, di ba? With non-zero mean. Although, dito non-zero mean, kasi yung mean natin 1, right? So ito yung coefficient siya, 0.18, yung mean 1.00. Yung mean is quite close, kasi yung mean natin 1. Pero yung AR component natin medyo malayo, no? Kasi 0.1 talaga yung ano natin, yung model natin. If you want to generate a time series which will give us a more accurate modeling, dagdagan natin yung observations. I think last time what we did here was to make this 10,000, for example. 10,000. Okay, so I make this 10,000. Okay, ito okay. Ulitin ko to, no? Control Enter. I run that. And then, ano na natin, no? Let's now get the ARIMA model. Tingnan natin if it will improve as compared to the first one. Control Enter. Yung forecast natin, pareho din 100. Okay. Take note, the P now is, wait, iba yata ang rinan ko, no? Apologies, ano ba yung rinan ko? Ay, large na yung rinan ko. Let me go back here, sorry. Sorry, dapat ito yung pinalitan ko, no? Ayan, ito yung pinalitan ko. So, if I run this, Control Enter. So, bago na yung AR1 small ko. And then, I will not anymore plot the ACF and PACF. If a forecast ko na kagad siya. All right, so take a look, class. Still the same, ARIMA 100, yung AR1 natin is 0.0136. Right? This is closer to 0.1. Okay? As compared yung kanina, ano ba yung ginawa ko kanina? 0.1. Na-delete ko yata, no? Okay. Anyway, class. Ito yung dinagdagan natin ng observations. Then, the answer was closer to the actual value. Okay. And then, okay, we already did that. Okay, how about this class? Let's increase the order a bit. Yung fee natin, yung coefficient. Okay, here. So we're creating this time another object, AR1.large, and we're still going to make use of the ARIMA.simulated. And n is equal to, let's just increase this by to 100,000. 100,000 observations, and model is equal to list, AR is equal to 0.9. Okay, so this time the 0.9, we're using a higher AR1 component. Standard deviation, let's just make it also 1 in order to make it similar to the previous one, and then plus A sub O. Okay, so let's run this. Control Enter. Okay, we should have this. Huh? Kasi 100,000 observations, kaya very compact siya. No? Had we, let's revert to the 500. If you use 500, then i-plot na natin to. Okay, you can now see that so stationary din siya, no? But if you compare the variance, looks like mas malaki itong AR1, no? Yung 0.9 yung ano yung coefficient niya. Okay. And then let's run this. Control Enter. Let's ask R to forecast yung ARIMA.1large natin. Okay, so that's ARIMA 100. Okay. AR1 is 0.86, which is quite a bit closer, no, to 0.9. Kasi di ba 0.9 yung AR1 component natin, and the mean is 1.31 when we made it as equal to 1. Okay, any questions so far, class? Kindly chat, please. It's clear. Okay, no questions. Let's wait for a few more of your classmates. I apologize for taking my time a bit kasi medyo nauuna tayo dun sa kabilang section, and I don't want us to be way ahead of the other section. That's why I'm biding my time so that at least we're on the same level, we're on the same page. Okay, now, as I said a while ago, can we see the forecast code again? Okay, sige. Forecast. Are you referring to this one? Yung ARIMA, no? So, using the ARIMA function of the forecast package, it will generate a solution where it shows what are the coefficients of the ARIMA. So ito yung object na generate natin kanina, di ba? So it's supposed to have a phi1 equal to 0.9. So when we run this, where the order of AR1 is 1, okay, if we run this, control enter, let me just close this first. Okay, so you can now see that indeed it was able to predict that this is indeed an ARIMA 1, 0, 0 with non-zero mean. With non-zero mean because we assigned it a constant. All right, then you have AR1 0.86, which is quite close to 0.9. But I said last time that if we increase the number of observations, then you'll have better results. The mean, which is supposed to be 1, is 1.3127. Okay, I leave you class to experiment. Okay, if we change the okay, one last thing before we move further. Okay, I ask a query here. Okay, this one. What will happen if we create an object AR1? Okay, so let me call this ano lang para maiba kasi AR1 yata yung kanina. I don't want to erase that. Let me check. A1 pala, hindi AR1. Okay, sige. Let me use AR1 now. Okay, so here, so now I'm getting ito class, no? So let's generate this AR1, arima.sim. Okay, maybe we can set that seed here. Set that seed tayo para pare-pareho tayo. Set that seed, may nating 222. Any number you like. Para 222 tayo pare-pareho rin tayo. And sa simulate na naman tayo ng 50 observations. Okay. And then the model is equal to, notice that your AR here has a coefficient of 1.01. Okay. Di ba hindi pa pwede yan to create an ARIMA process kasi okay, your phi1 is greater than 1. Hindi pa pwede yun. So if I run this, okay, it tells us that yan, error in arima.sim, okay, AR part of model is not stationary. Bakit class? Kasi ito, 1.01, di ba? It's greater than 1, so hindi yan stationary class. If we use, paano kung 1.0? Kung 1 class, run natin to. What happens? Ganun din, no? Ganun din. C is equal to 1. Okay, that becomes what class? Anong data, anong klaseng data yan class? Pag C is equal to 1. Anyone class? We just discussed this a while ago. Yung phi1 natin is equal to 1. What does that become, class? Okay, yes, thank you. Thank you, Jerome. It's a random walk, no? Random walk yan. So it's a non-stationary explosive series yan. Kasi walang direction siya eh, kung saan lang siya pupunta. No? And siguro class, ang assignment nyo next time is try to generate this equation. Yung random walk, yung y sub t is equal to y sub t minus 1 plus a certain error term. So generate that and plot that and see how that looks like. As compared to, ito, yung mga ano natin, yung phi1 natin, di ba? Pag yung isa kanina 0.9, 0.1, isa 0.9, even if we change this, no? Okay. I'll do this, I'll make it negative 0.5, for example. So pwede ba yan? Yes, pwede to, class. This is okay. Why is that so? Kasi 0.5 yan eh, di ba? It's 0.5. So it's the absolute value of that is less than 1. So this will work. Okay, so i-plot natin to. Plot natin yung object na to, Control Enter. And you'll see that it's a stationary data series. Yan, stationary siya. That's stationary, di ba? Ano nangyari doon? Hindi, yung 1 yan eh. Ito class, di ba? Ito, no? Yung negative 0.05. So that's stationary. Okay, now let's go to how about class if it's an AR2 process? Okay, if it's an AR2 process, so kailangan class dalawang component yung dapat may phi1 and phi2 tayo, di ba? So let's try this, no? Let's try this. AR2.sim, okay? It's arima.sim, model is equal to list, and then AR is equal to, I'll ask you to write this class, no? So I'll give you a few seconds to write that. You're done, class? If you're done, kindly chat. Tell me if the plot that you're getting and yung model, yung ARIMA model class. Okay, is it close to ilan ba observations natin? 500 lang naman, no? It might not be very close to 0.9, but is it okay, class? Pwede ba tong combination na to ng phi1 and phi2? 0.9 at saka negative 0.2. Will that work? And then if we ask forecast package to model it, yung order natin 200. This means 2 lags of AR process and walang hindi integrated at saka walang MA. Include that constant is equal to true kasi may A sub O tayo dito, constant, no? And our A sub O is 1, di ba? Existing pa naman yun. Okay, so tell me class what happened. Para pare-pareho siguro tayo mag-set that seed tayo na 999. Anyone please? Can you please comment? Pwede ba yan class? Yung phi1, what we learned is that for AR1 process or for MA1 process, your phi1 or theta1, its absolute value should be less than 1. Okay, so hindi siya pwedeng greater than 2 or less than, hindi siya pwedeng negative 1.5, hindi pwede yun. No? So if you get the absolute value of that, mas malaki yung kaysa 1. Okay, anybody? Any volunteer? What do you get here, class? Wala pang sumasagot? Yes, let's see. Okay, Vincent, could you explain, please? Sorry, Vincent, I keep on forgetting that you might not be understanding Filipino. So please remind me if I speak in Filipino, then okay. Yes,
It's okay,
Vincent. Yeah, could you explain what happened in your case?
I don't know how to explain it, but
okay,
from the
maybe
results, it's just
yeah, maybe I should
stationary graph.
yeah, maybe I should ask you to share. So let me stop share, and then let me share again. share screen, and then okay. Vince, you have the floor.
Okay, I'll choose.
Could you share your screen, please? Okay, there you go. Let's see. Could you click that, please? All right. So you can see, class, that that's possible. If phi1 is 0.9 and phi2 is negative 0.2, it worked. Okay. And then could you flash also the model? Okay. What are we getting? AR1 is 0.92. Okay. And AR2 is negative 0.2. So it's pretty close. And the average is 0.85. The average that we set is 1. Okay, we will not expect really that it will be very close because we only have 500 observations. Okay, so thank you, Vince. Thank you. You're correct. All right, so let me get back. Let me share once again my screen. Okay, so I hope you got that, class. Okay, what I wanted to point out here is how do we know, class, if in AR2 process, what should be the requirements for, let me, let's see, annotate. Annotate natin. So for AR2 process, AR2, because we know that in AR2, there should be two coefficients, right? AR2 process is, from what we know, y sub t, right, is equal to, if we have a mean or a constant, phi, right, plus phi1, okay, let's write it this way, b times y sub t, okay, plus phi2, b squared y sub t, plus an error term. All right, so this is a new way that we learned to write our AR process, or it's MA pareho lang, the same. No? You can use B or you can use L. So this is backshift operator. This means by sub t, since it's understood that the exponent here is 1. This is 1. It means that this is log of 1. So by sub t is the same as this one is y sub t minus 1, right? And this one, b squared y sub t, we know that this is y sub t minus 2. Okay, so that's just nomenclature, naming, just being aware of how this is written. All right, so you have now phi1 and phi2. So what are the requirements, okay, for phi1 and phi2 to be to generate an AR process? So the requirements are the same. Okay, first is that the absolute value of phi sub 1, okay, its absolute value should be, okay, let me start with phi sub 2. The absolute value of phi sub 2 should be less than 1. Okay. Also, the absolute value, let's check this, class. Absolute value of phi sub 1, okay, is less than 2. Okay. And then lastly, let validate this, class, if this is correct. Lastly, phi1 plus phi2 should be less than 1. Okay. So these three conditions. So first, phi sub 2, the second, the log 2, this one, this should be less than 1. Phi1, okay. So the question is it okay for this to be less than 2? And then thirdly, the sum of phi1 and phi2 should be less than 1. So let's take an example. So let's make phi1, let's make phi1 1.5. Let's see. 1.5. And then let's make phi2 as negative 3. Okay. Will this hold? Will this hold? No, this will not hold because your phi2, your phi1 is 1.5, your phi2 is negative 3. 1.5 plus negative 3, that's Okay. Sorry. Negative 0.3. I'm sorry. Not 3. Negative 0.3. This is not okay. You know why? Because 1.5 plus negative 0.3, that's 1.2. Okay, and it will violate this third rule. Okay, so what other example can we think of? Let's see, how about 1.1? Okay, so this is your phi sub 1. Okay, and according to this rule, this is acceptable because 1.1 is less than 2, right? And recall that in AR1 process, this is not allowed. So is this rule okay? Where phi1 can be greater than 1, but it should not be greater than 2. However, if we add both phi1 and phi2, it should be less than 1. Okay, so 1.1, okay, let's make it 1.2. And then, so this is your phi1. And then your phi2, let's make it negative 0.4. Okay, so let's try this. No? So this is your phi sub 2. So this is okay because this is negative 0.4, right? It's less than 1. This is phi1, okay? Phi1 is less than 2. This is less than 2, 1.2. And then if we add this 1.2 plus negative 0.4, we're getting 0.8, and it's less than 1. Okay, so let's try that, class. Let's simulate a data, an AR2 process. Okay, so take note, 1.2 and negative 0.4. Okay, before we do that, class, are there any questions with the example that we're trying to simulate? Is this clear, class? So this is the rule for an AR2 process. Okay, your phi sub 2 should be less than 1, absolute value, and your phi sub 1, absolute value, should be less than 2. However, there's a third rule. If we add both, okay, if we add both phi1 and phi2, they should be less than 1. Okay, so we're now creating a phi1 is 1.2. Take note, class, that in AR1, this is not allowed. 1.2 is not allowed. Okay, but in this case, let's see. 1.2 yung phi1, and then our phi2 is negative 0.4. Okay, so let me clear our drawings. Let me close this. And then so this is okay. So why don't we now just copy this, Control C, and then Control V, and then let's phi1 is equal to 1.2, and then phi sub 2 is equal to negative 0.4. Okay? All right, so let's replace this. AR will be, so this is 1.2, and this should be 0.4, right? Okay, so let's just call this, okay, whatever you want, class. I'll just call it AR21, 21, 21, just to preserve the two a while ago. All right, so please tell me what happened, class. Did it run? I'll wait for you, class. So this should be, make this 2-1, class. Make sure we change the name here. 2-1, 2-1, 2-1. I'll give you a few seconds. Comment? Anyone? Okay, so we have the first comment here. Oh, Jerome, sabi ni Jerome, the code run, no? Okay, the code run. Okay. How about the others class? Okay, Rogel also. Sorry. Yeah, Rogel. Okay, then. All right. Good. Okay, Vince also said it run. Okay. So which means class, this validates the rule that for AR2, the absolute value of phi 1, okay, can be less than 2. So this is not like the AR1 process, where in AR1 process, the absolute value of phi 1, okay, should be less than 1. For AR2, the absolute value of phi 1 can be less than 2, should be less than 2. The absolute value of phi 1, phi 2 should be less than 1. And their sum should be less than 1. Okay, good. For all of you, it run. So let me just run it in my case. All right. So there you go. And the model that was generated is, so 1.2, negative 0.4, and a mean of 0.77. What mean did we use here? The mean is, I think, the same. A sub O, that's 1. Okay. All right. If we had used more sample size, the model would have, the ARIMA function would have generated a closer value to the simulated value. Okay, so all right, for MA class, it's the same thing. Okay, the only difference is that I would that you practice class, you just change this MA. Instead of AR, you make it MA. Okay, same rule for AR1 and MA1. Okay, the theta 1 should be less than 1. Same everything. So this is okay, 0.3. Okay, but of course here, when you do the ARIMA, it should be order is equal to C001 because it's an MA process. All right. So I leave that to you as an exercise class. Also here, class, for MA2, is this okay? Yeah. 0.7 and 0.1, this is okay. Negative 0.7, no problem, because phi 1 should be less than, absolute value should be less than 2. Okay. So if we do an AR-MA2 process, you just add here to the theta sub 2, and then just make sure that you follow the rule. Okay, same thing. All right. So okay, so I think you practice. There are rules also for the higher order AR and MA, but we will not go into that. No? We will just stick to AR1 and MA2 and try to see if there's a rule as far as ARMA 1.1 and ARMA 2.2 is concerned. Are there rules about theta 1? Because for ARMA 1.1, there's an phi 1 and theta 1. Is there a rule about that? How about an ARMA 2.2? You have a phi 1 and phi 2 and theta 1 and theta 2. So how about that? How do you generate that? How do you determine that? Okay. Here we're checking we're testing if the simulated object that we generated is stationary. You can do that, class. You know how to test. And then you can also, so that's please do that as an exercise. Any of the simulated values that we generate, you can check if they're statistically, if they're stationary. Okay. We have shown by the plot that they're stationary, but you can use ADF test and KPSS test, etc., to check if they're stationary. You can also test, you create their ACF and the PACF test and see if indeed, for example, our AR1 process, if indeed it will show if it will show an AR1 process based on the PACF. Okay. All right. This is just the same. And for next meeting, we're now going to predict. We're going to learn how do we predict the values, let's say for the next 10 days, for the next 20 days, etc. And then we will do diagnostics. Okay, we will see if our model is okay based on the residuals that we generate. Okay. So sorry for the extended time. Thank you so much, class. I hope you learned something. Let me stop recording.